QET, a series of educational courses. Please like and share this video and subscribe for more promotions of the videos. Thank you. Bismillahirrahmanirrahim. In this lecture, we are going to discuss some of the n-derivatives and differential of the functions. So here we will find n-derivative of the function y is equals to exponential of x, cosine square x, sin x, and the other function is y is equals to x ln x. So let us see how we do this. To find the solution of the first question, we must remember some of the formulas which are used in this, so these formulas are cosine squared theta is equals to 1 upon 2 1 plus cosine 2 theta, and the other is cosine alpha into sine beta is equals to 1 upon 2 into sine alpha plus beta minus sine alpha minus beta. So now let's suppose we rearrange this function exponential of x cosine square x sin x using these formulas, and then we will have exponential of x into 1 upon 2 1 plus cosine 2x into sin x. Now when you simplify, you will get 1 upon 2 exponential of x into the sin x, and then plus 1 upon 2 of exponential of ax into cosine 2x into sin x. Now we will keep the first part as it is same, and the second part we can apply the formula of cosine alpha into sine beta. So now using this formula we will simplify, so we will get exponential of x and then sin x plus 1 upon 2, and then we will have exponential of ax same, and then multiply by sin 3x minus sin x all divided by 2. So rearrange this and simplify, you will get the y will be equals to 1 upon 2 exponential of x and then sin x, and then plus 1 upon 4 exponential of x into sin 3x, and then plus 1 upon 4 minus 1 upon 4 exponential of ax into sin x. So now simplify, these terms will be cancelled out with this last term, and then finally you will get minus 1 upon 2 exponential of ax sin x, the simplification of the first and the third term, and then you will have 1 upon 4 exponential of x into the sin 3x. So now this is your y. Now you can apply another formula to find the n derivative that can be obtained from the books. So now applying this formula, that is n derivative exponential of ax sin bx plus c will be equals to bracket x square plus b square power n upon 2 and then sin bx plus c into n into 10 inverse of b upon a. So using this formula, the n derivative can be obtained. So the n derivative is minus 1 upon 2 and then a square same, and then plus b square, so replace b by 1 because in sin bx plus c we have sin x only, so here we have 1 whole power n upon 2 into the sin x, and then plus n 10 inverse of b upon a, so b is 1 upon a. Now note that here we have to multiply the exponential of x, there is also used here. So the second term plus 1 upon 4 will be same, that is the coefficient, and then exponential of x, we can take it outside if you want, and then a square plus, and instead of a we have b, we have 3 here, so 3 square will be equals to 9, and then whole power n upon 2, and then we have sine of bx plus c, so here we have simply 3x, and then plus n into tan inverse of b upon a, so here we have 3 upon a. So this is the solution, that is the n derivative. Now let us see the solution or the proof of y is equal to exponential of x sin bx plus c for the nth order derivative that is used in this solution of the problem. So now in this case, if you take derivatives of this function now, taking the derivative, so we have y1 will be equals to by product rule of derivative exponential of ax into a. So now I am writing a here. This is derivative of exponential of x, keeping sine bx plus c same, and then taking derivative of sine bx plus c, keeping exponential of ax same. So this will be cosine bx. This will be cosine bx plus c into b. So now if I use this supposition that a is equals to r cosine theta, b is equals to r sin theta, and then substitute the first derivative by 1, so I will have exponential of x is common, and then we have a is equals to r cosine theta, and then sin bx plus c same, and then the next term will be plus cosine bx plus c, and then b is equals to r sin theta. So now simplify this, taking r common. So we have the first derivative will be exponential of x into r, and then we have cosine theta sin bx plus c, and then plus cosine bx plus c, and then sin theta. So now when you simplify, you will get the first derivative will be equals to r into exponential of x, and then you will have sin bx plus c plus theta. Here we apply the formula of sin alpha plus beta is equals to sin alpha cosine beta, and cosine alpha and plus cosine alpha sin beta. So now this is the first derivative. Now if you consider what is the change in this, in the first derivative we have r power 1. However, in the given formula exponential of x sin bx plus c, there was no r. So when we have zero derivative, there is no r because r power 0, and then there is no theta, 0 theta. Similarly, in the first derivative we have r power 1, and then the function is same. In the angle we have 1 theta. So in similar manner, when you simplify, you will get y2 will be r square exponential of ax, and then sine bx plus c, and then plus another theta, so this will be 2 theta. So in this way, when you continue this, you will get the nth derivative will be r power m exponential of ax, and then sine bx plus c, and then plus n theta. Now to place the value of theta, so from this theta will be equal to tan inverse of b upon a, and also the r is equals to square root of a square plus b square. So substitute these values into the formula, you will get the yn will be equals to a square plus b square whole power n upon 2, and then exponential of ax sine bx plus c plus n into 10 inverse of p upon n. And that is the formula we have used in our problem for finding the n derivative. The next function is y is equals to x ln x. We have to find the nth order derivative. For this one, what we do, we first find the formula for ln x. So if you see this, let's suppose our function v is equals to ln x. So if you take derivative, this will be equals to 1 upon x. Now you take another derivative, this will be equals to minus 1 upon x square. One more derivative will give you minus 1 into minus 2, and then divided by x cube. So in this way, when you take the nth derivative, this will be equals to minus 1, and then minus 2 goes to minus n minus 1, and then divided by x power n. So how it is? So we see that first derivative is 1 upon x. Here the power of denominator the variable x is 1, and derivative is also 1. And second one, we have v2, derivative is 2, so power of the x is also 2. In denominator we have minus 1, and then in v3 we have minus 1 into minus 2, and then divided by with the same power 3 and derivative 3. So now we can also write the same thing in this way. In the first derivative we have minus 1 power 0 into n factorial. So we can rewrite these derivatives in this way: minus 1 power 0 into 0 factorial divided by x power 1, that is equals to 1 upon x. Similarly, we can write minus 1 upon x square in this way: minus 1 power 1 into 1 factorial divided by 2 divided by x square. And similarly, v3 will be equals to minus 1 power 2 and then 2 factorial and then divided by x power 3. So continuing in this way, we can also write the n derivative of v, that will be equals to minus 1 power n minus 1 into n minus 1 factorial and then divided by x power n. So now we will use this formula, that is the n derivative of ln x, into our function to find the n derivative of x into ln x. So by Leibniz theorem, let's suppose this function is u. So let's suppose u is equals to ln x, means the first function is ln x. Then from the recent derivative we obtain the n derivative of this fraction will be equals to minus 1 power n minus 1 into n minus 1 factorial divided by x power n, and then n minus first order derivative will be minus 1 power n minus 2 and into n minus 2 factorial divided by x power n minus 1. And also let the second function v is equals to x, then derivative of this will be 1. Now we can apply the Leibniz theorem. So Leibniz theorem up to the term y1 goes. After this the other derivative will be 0. So by Leibniz theorem, the n derivative of u will be equals to combination 0 out of n un v plus combination 1 out of n and then un minus 1 and then v1. So all the other terms will vanish. So we just simply write this, and then the next step we will remove these terms. So now substituting the values, the value of n r is equals to n factorial r factorial and then n minus r factorial. This is for combination formula. So when you put 0, this will be equals to 1, and then n derivative of u, that is minus 1 power n minus 1 into n minus 1 factorial that we obtained from here, and then whole divided by x power n into the first derivative of v, the function v itself, so this will be x. We can cancel this. Now the next term When you substitute 1 into this formula in place of r, you will get 1. You will get n. So this will be n, and then the n minus 1 order derivative, n minus first order derivative of u will be equals to minus 1 power n minus 2 into n minus second n minus 2 divided by x power n minus 1, and then first derivative of v will be equals to 1. Now just simplify this. So when you simplify, we will have 1 upon x power n minus 1 in both of these terms, and then what is our left over part is minus 1 power n minus 1 into n minus 1 factorial, and then we have plus n minus 1 power n minus 2 into n minus 2 factorial. So that is the n derivative. However, if you want, we can simplify it further, but we stop here. This is the n derivative of the given function of, what was the function, x, ln x. So in this problem, the power P consumed in a resistor is given by the equation or formula or the function P is equals to V square upon R. That is the function of two variables, that is V and R. Determine the approximate charge, means total differential of this function in power V increases by 5%, and R decreases by 0.5% if the original values of V and R are 50 and 12.5. So let us see the solution of this problem. Now point to note here that the function P is function of two variables V and R, defined by here V square divided by R. The second thing is that the values of V is given here. V is 50 and value of R is 12.5, and if V increases, so there is the value dV, that is also equals to delta V, and that is the 0.5% of the original will be increased by 5%, means 5 into the original value, that is 50 divided by 100. So now this will be equals to, if you simplify, you will get 25 divided by 10, and then this will be equals to 2.5. So in similar manner, here the value of R decreases, that's given here, that R decreases by 0.5%. So the change in R will be 0.5%. So multiply the 0.5 with the value of R, that is 12.5 here, and then divided by 100 to get the now value of the change, that is decreases. So we place a minus sign because of the decreases, and then when you simplify, you will get, so these are the data, the function, the value of V and R, and then change in V and change in R. So using the formula of total differential, we know that if Z is a function of two variables, such as Z is equals to Z of x comma y, then the total differential dz is actually equals to tau z by tau x dx, and then plus tau z by tau y dy. So tau represent the partial derivative. So in similar manner, so when we have the function p, so its differential dp will be equals to tau p divided by, or tau p by tau v, and then dv, and then plus tau p by tau r into dr. So now just substitute the values. So when you simplify and get the values, this will be equals to derivative of v with respect to v. So derivative of v with respect to v. In this case, r will be constant because we are taking the partial derivative indicated by Dava symbol. So this will be 2v divided by r, and then dv same, and then plus derivative of v with respect to r will be equals to v square minus v square divided by r square, and then the r will be same. The r will be same. So now just substitute the values into this, and then you will get the results. So here we have 2 same. The value of v is 50, and then divided by r, that is 12.5, and then value of dv will be equals to 2.5, and then minus sign because of this one. So v square, v is equals to 50 square divided by r square. So r is 12.5 square, and then dr, that is minus 0.0625. Now just simplify this. So this part will be equals to the left. The first term will be equals to 20, and then plus 1, and when you simplify you will get 21. That is the solution, or the approximate change in the power.